As part of a local arts festival, an artist plans to create an installation in which a concealed water cannon blasts a stream of water into the air for a few seconds at random intervals. The lengths of the intervals between each firing of the cannon can be modelled by the uniformly distributed random variable t, where t is between 3 and 14. Sketch the probability density function for the interval between each firing on the axes below. So if it's between 3 and 14, we know that there will be probability between these 2 points, and it's uniform, so it's going to be a horizontal straight line. And then it's just going to be 0 everywhere else. We know the area of this rectangle has to be 1, so with a width of 11, 14 take away 3, the height of it has to be 1/11th. If we were to actually write the probability density function down, then we would have f of t is equal to 1/11th if t is between 3 and 14 and 0 otherwise. So 1/11th between here and here, remember that's so that the area of the rectangle is 1, and 0 everywhere else. So we want to determine the probability that randomly chosen interval between firings is at least 7 seconds. So let's say that 7 is here. At least 7 minutes. That would be this area here. What we're looking at here, at least 7 minutes, is the probability that t is greater than or equal to 7. So it's this area here. So this is 7, between 7 and 14, and we know the height is 1/11. So it's the area of this rectangle, which is 7/11ths. So the next part of the question says, at least 6 minutes given that it's less than 10 minutes. So that's the probability that t is greater than, doesn't matter whether it's greater than or equal to or greater than 6, given that t is less than 10. So that's the probability that t is greater than 6 and t is less than 10 divided by the probability that t is less than 10. That's just the probability of A and B being equal to, A given B is equal to the probability of A and B divided by the probability of B. It's just that formula. Now, to be greater than 6 and less than 10, we're talking about the probability that t is between 6 and 10 divided by the probability that t is less than 10. Now, if we go back to our diagram up here, if we think about the 6 to 10, that's a width of 4, so that's 4/11ths. And if we think about less than 10, that's this whole rectangle here. That's 3 and 10 there, so that's a width of 7. So that would be 7/11ths. So what we're talking about here is 4/11ths divided by 7/11ths. Turn this upside down and multiply, and we get 4/7. Now finally, we want to find the value of t, for which the probability of t being less than t is equal to the probability of t being more than 4t. So there's some value here t, such that this value here is 4t, and these two areas are equal. Now think about the probability here. The width is t minus 3 and the height is 1 over 11. So that's t take away 3 over 11 when we multiply them. That's got to be the same. This is 14 take away 40 as 14 take away 40 over 11. Well, we've got the same denominator, so we can ignore that. T take away 3 is 14 take 40. So 5t is equal to 17, and t would be 17 over 5.